Hello everyone. Today we are going to solve the geeks for geeks, Ceil in the binary search tree and the floor in the binary search tree question. So both question are same on the same pattern. So I decided to solve both question in same video. So first discuss the Ceil in the binary search tree. So we have given a binary search tree and a number x. We have to find the Ceil of the x. So first discuss what is the Ceil number. So a number that is either equal to x or immediate greater than x. Like uh, like if we talk about 5, so the value 5 equal to Ceil. Otherwise, the immediate greater value like 6 is equal to Ceil. But in this case, we have given a binary search tree. So a value that are given can be the node of the binary search tree. So if it is the node of a binary search tree, then we will return the node. Otherwise, Otherwise, we will return the next node, means immediate next node to the this tree, immediate next node to this tree. So, like in this example, we have given uh, x equal to 3, and we have given this binary search tree. So, how we will find, we start from this root node. This is our root node. We start from this node. The property of binary search tree, like all the values on the left side, is less than the value of the root, and all the value on the right side is greater than the value of the root. So if we have to find, then the value, of course, will lie on the left hand side. If the value is less than root, then the seal value is lie on the left hand side. If it does not lie on the left hand side, then our root value will be the immediate next value, means it will be the our seal value. So otherwise, if the given value x equal to our root, it means we found the seal value, we will return this value. Otherwise, we go to the right side and check this same procedure once again. So let's see how we are going to solve this problem. We are starting from the root. We are starting from the root. So if our root is null, we are going to make a recursion call. At the end, if we go to the null, means we cannot move further, we cannot move our pointer to next because it is null, so we will return -1. So if we get -1 from the left side, then this node is our seal. First we make a left recursion call. We go to this one. For this one, we make a recursion call for the left. Left gives us -1. Root 3 is not equals to 1, then we make a recursion call for the right. For the right, then again we make a recursion for the left, it gives -1, and 2 is not equals to 3. Then we go to the again right. For when we reach at the 3, like uh, our x is equal to root dot value, then we return the 3. We return 3 to this, then this to return 3 to 1, then 1 return 3 to 5, and 3 is returned to our main function call. So it is the case where we get the value, the node exists and we have to return the node. Let's see another example where the node does not exist, means the value does not exist in the tree. Then we have to return its next node. We have to return its next node. Like, let's see, we start from the 10. Our value is 6, means it will obviously lie on the left hand side. It will lie on the left hand side. So we go to the 5. Then we go to from 10, we go to the 5. Then 5, we again check that our value 6 is less than, our value 6 is less than 5. So no, it is not less than 5. So means the value does not exist on the left hand side. The value will exist on the right hand side. Then we go to the right hand side, we go to the 7. We go to the 7. When again at 7 we check that is 7 equal to our given value. So 7 is not equal to our given value. Means the value, steel value lies on the either left hand side or the right hand side. Then what is the means condition? Our condition means value. Our given value is less than root value. When it will lies on the left hand side, it is fixed. It cannot be on the right hand side. So for the left hand side, what is the value? There are no nodes, so it will return -1. So if it will return -1, then this node, like this parent node, will be our seal because left hand side does not value. But what is the immediate next value? The immediate node is 7. We will return 7. So this is the whole approach. Let's see the code of the seal value. Like if our root equal to null means we do not find the seal value, then we will return -1. One thing we have to keep in mind, we do not need to return the tree node. We need to only return the value of this tree node, like value of this node. So after that, we check our main condition, like our given key is less than root the data means it is 100% sure that value lies on the left hand side. Then we declare a variable left and make a recursion call for the left hand side node or left node. If we get the value on the left node, if we get the value on the left node, then we return our left. Otherwise, we return our current root dot data. Like in this case, we can see we did not get the value on the left hand side, then we return the root, means we return the parent. So left equal to -1 means we did not get the value from the left, then we return root dot data. Otherwise, we will return our left value. Else if case like our key equal to root dot data means we find the seal, we return the root dot data. Otherwise, then we go to the right. Then we go to the right if do not find the answer. On the left side or on previous two conditions, do not find answer, then we go to the right and make again this recursion call. We will again make this recursion call for root dot nine right value. So this is the simple approach for the seal value. Ah, let's see for what is the for the floor value. So floor value means if we find the node, then we will return that node. Otherwise, we return the value that is like one step before this, like a smallest node, smaller than the smallest node, means what is the previous value, like you can say previous value. So like we have given this question, we have 7 node tree and our number is 87. We have to return the floor value. Floor value, if we get the value, then we will return like in this case, we have value 87, then we will return 87. Otherwise, like in this case, we have given the value 4, like we have given the value 11. So 11 does not exist in the tree, so we have to return 9 from this tree. So this is our answer how we are going to solve this problem. So let's dry run this code. First, let's understand how the code is working. Like it is similar to the seal of the binary search tree. In the seal of in seal of binary search tree code, we are checking for the left hand side. Like value lies on the left hand side. In this case, we will check the value lies on the right hand side or not. So if root dot data equal to x, then we will return root dot data. In else if case, if root dot data is less than x, means the value lies on the right hand side. If our root dot data is less than x, means less than x, then our value lies on the right hand side. So we go to the right hand side. Like obviously it is 100% true that we will find the value on the right hand side. If we find the value on the right hand side, means for this, if you see, like we have given the value 86, like we have given the value 86 in this example. We go to the 2 who is less than 86, then we go to the right side. Then for for this, we go to the left side, right side, where we go to 81 is less than 86. So obviously next value lies on the Next value lies on the 86, like a right side. Next value lies on the right side. Then we go to the 87. Now 86 is less than 87. We cannot go to the right side. Then we have to go to the left side. Left side we get the -1. So we get the -1 from the both right side and from the left side. We get the -1. So if we get the -1 means it should be on the right side, but it is not present. So if it is not present, then we will return 81 in this case. So this is the whole code. Like we go to the right side, row dot right comma x. So if right equal to -1 means we did not get the value on the right side. It should be on the right side, but did not get the value on the right side. So we will return our root dot data means what is the parent, because if the value does not lie on the right side, what is the means value that is the immediate to this. Like what is immediate value? Like the node from where we are making the request, we are making the recursive call is our value, so we will return root the data. Otherwise, if we found our answer, then we will return the right. In this case means value is greater than, then we have to, sorry, value is our less, like this 86 is less than this value, so we will make a left call. For the left call, then again all the work will repeat itself. So both question can be solved like in order traversal as well. Like if I see you in order traversal, we start with 2, then 42, like we start 2, 42, 45, 66, 81, 87, 90. We have to return 87. We found 87. For 86, what is the previous value? Like we cannot go to the 87 because it is greater than 86. So we will return 81. So this is the recursive solution. This is the recursive solution. We can make a in order traversal, like we make a in order traversal and store all the values like 2, 42, 45, like this. And if we found the value, then we return the value. Otherwise, if our value is greater than, like we reach 87, like we reach 87 means at this particular we found 87 means the value cannot be on the right side, value is on the left side, so we return the value that is just before this, then we return 81. Simple answer. Like very simple answer. Like in this case, for this value also we make a in order traversal and we found the node. So if node is present, like let me dry run this. Like we make a list, we make a in order traversal. So 4, 5, 7, 8, and 10, and 11. So this is our in order traversal. Always remember, in order traversal in a binary search tree give us the sorted array, give us the sorted list. So we start from 4, we have to find 6. We start from 4, 4 equal to 6 or greater than 6. So 4 is less than 6, then we go to next. 5 is less than 6, then we go to the next. 7 is greater than 6, then we will stop here. We will stop here and we will return this value. Sorry, sorry, we have to return the seal. Seal. We have to return the seal value. So we go to the 7. Is 7 equal to? Means if it is less than, then we go to the next. Otherwise, we will return this node, then we will return 7. Very simple. If we found this node, then we also return. So if the value is less, then we go to the next. Otherwise, we will return the value. So this is all the approach. Since in this approach we are using extra space, like we are using big O of n space, like we have n nodes, so we are using big O of n space. That's why I avoid this approach and use a recursive approach. You can also try that we store the previous value, like a previous node or next node, current node, like this, and we return the constant. But this approach, like I like this approach, so I solve this problem by this approach. Thank you for watching this video.